the maze 3. So this is gonna be continued with the maze 1 and the maze 2. If you can solve the maze 1 and the maze 2, you can continue to solve maze 3. Yeah, just need to consider there's a little bit difference. So for maze 3, we just need to make this ball into the hole. It cannot be at the end. It can be anywhere. Yeah, it means if the ball go up and go left, if it can go to the hole. So we're gonna have an answer. Yeah, and there's another way the ball will go left first and then up and then left. It can still go to the hole and the distance is the same. But we're gonna return the lexicographically minimum one. So it means we're gonna return this one, LUL. So L is the direction left, U is up, and L is left. Yeah. So there are a lot of edge cases we need to consider. Yeah, but I'm gonna solve it according to the maze 2. I'm gonna use the Dijkstra's algorithm, the shortest path, to solve it. Yeah. Now let me copy the code from the maze 2. So so here I'm gonna use my code from the maze 2. You can also check it from my YouTube. I posted the videos for the maze 1 and the maze 2, but basically you can check the videos for maze 2, and then you can continue to solve this one if you are going to solve it. Yeah, let me just check the connections. I hope the connections should be okay. So let me check. Yeah, I believe the directions should be. Yeah, I think the directions is okay. Now let me just continue. Yeah, continued with the maze 2. I'm gonna change a little bit about the maze 2 to adapt it to the maze 3. So let's just continue. So this is a priority queue. I'm starting from the distance from the beginning. It's gonna be 0, and this is the starting point. Yeah. And here I'm gonna have the ball. The position of the ball is not the start. So I'm gonna just copy and paste with the ball. And yeah, let me just replace the start. And here is the start. And let me just replace the hole. And it's gonna be the destination. And here is also destination. Yeah. Now let me add another variable. So inside the priority queue, I'm gonna have an empty array. Yeah, because I need to return something like the directions, like LU and L. So I'm gonna, in the second place, I'm gonna prepare an empty array. And finally, I'm gonna return this empty array. So here, so for the priority queue, I need to pop out the distance, a string. If I find it, I'm gonna return this string s. Yeah. Now let me check others. So for the R and C, it should be the same, and the directions it's gonna be the same. And also with the distance array, it's gonna be totally, exactly the same. But I need to prepare another variable because I need to update the path. If I have a smaller path, for example, this from the beginning, I'm gonna go up and left. It is UL, but LUL should be better. Yeah, but how should I update with this LUL? So I need to have another DP array. So it's gonna be a path. So inside the path, I'm gonna use a 1D array. So it's gonna be the same as here, the distance array. Yeah, because I think turn 2D array to 1D array is gonna be easier to understand, but actually it's the same. You can also use 2D array as the dist, but I prefer to use 1D array. So inside the path, I'm gonna give a letter Z. So this Z just means, because for 4 directions, it's gonna be LU, R, and D. Yeah, and all those letters should be less than this length. So I'm gonna give a maximum impossible value. It's gonna be that. If it is less than the path, I'm gonna update it. Yeah, and I will update this path with this dist array. Yeah, if I need to update the dist array or I need to update the path, I'm gonna have a condition to check. If there is a smaller path, I'm gonna update the smaller path. Yeah, only when the distance is equal, I'm gonna update the path array. Now let's check what else I needed to add. So here, yeah. So in this check function, I'm gonna return 4 values, not 3. I'm gonna return a distance, and I also need to return a character. And this is the distance array. Why I need to return this character? Because I'm gonna update the character inside the priority queue. Yeah. So if it is smaller, I'm gonna update it with this character plus this string s. So here, it's gonna be s plus the character. Yeah. Up to now, I need to finish this check array. Yeah, because inside of the check array, I'm gonna add this character. So how can I add this character? Now, I needed to have a map to map the directions. So I'm gonna use letters. Yeah, I'm gonna use a direction map. So the directions would have a map. It's gonna be tuples with yeah. Let me copy the 4 directions. So this 0 and 1, it means it will go to the yeah. It means it will go up. Yeah, because in those it didn't change, but it will go to the, it's not up, it is left because the column should +1, it is right. Yeah, so this will be R, and let me yeah, just copy and paste with all others. Yeah, now 0 1 0 -1 should be left, and 1 0 should be down, and -1 0 should be up. Now, yeah, I also have a direction array. According to this direction array, I can get a result for the letters. So here, I'm gonna use this direction array. Inside of the direction array, I'm gonna have a tuple with row and column. So it's gonna be R and C. Yeah. So this is for the case if the host is at the edge. I mean, it is close to the wall. If the host is just in the middle, it is like this case. So we need to have a tag. So if R equal to whole 1, whole 0, yeah, we have a whole 0, and C equal to whole 1, it means I've already found a position, so I cannot pass the hole. If I go like this way from the left to the right, I can only put it inside the hole. I cannot pass it. Yeah, so I have to have a tag from here. If yeah, I find the position, I'm gonna return, and let me copy it. So the distance should be just the dist. I don't need to use -1 because -1 it means I go into the wall and I need to go back. Here I don't need to go back. So here I also don't need to use minus with dr and dc. So this is the case if I can go into the hole, or if I need to hit the word, go inside the word, I need to go back 1 step. Yeah. Now I've finished the check function, and I also have a direction map. Now my value should be updated from here. So this is the character, But this is just one case if the distance plus d less than the distance this neighbor array. But there is another case. Yeah. So another case is if this is equal. Another case is all. Yeah. So if the distance is equal, I'm gonna check if there is a smaller letters path. There is a lexicographically minimum one. Yeah, I'm gonna update the minimum one. So if the distance is equal and s plus character is less than my path, so the path will be row and column. It is not row and column because I've already turned it to 1D array. So the path would be the same. Here I'm gonna use a variable p. So p should equal to the positions. Yeah. So the positions p should be equal to row times column c plus the column. Yeah, because I turned it to 1D array. So here gonna be a path p. Now if it is like that, I'm gonna update the path. Yeah. So the path with p should equal to s plus character. Yeah, and inside here I can also use path p, but just to make it like that, I think it is also okay. If it is not possible, I'm gonna return impossible. Yeah, because we need to return impossible, not -1. And here, let me check if this is s is okay. I think it is okay. Yeah, let me check if there is anything missing or typo. This is the check function, and here and here. I'm gonna have a dist array. Yeah, let me just run it to check if it is okay. Yeah, it seems that there are mistakes. 4 and 5. Return this one directions R and C. Yeah, this is a key error. It's difficult to find 0, 1. 0, 1, it is the left, 0, -1, 0, 1, right, left. This is a go. Yeah, key error means I just cannot find the value. Yeah, it means something wrong with my direction map. -1, it means go up, 1 means go down. Yeah, I think I need to print out the direction. Maybe there's something wrong with the direction map. And not the direction. I think it's yeah, name direction. It's not the direction. It's a key error. Yeah. Distance -1. Direction RC. Yeah. Direction RC. Yeah, key error means I didn't find the key. So here is what I did it wrong. It should be dr and dc because dr and dc are directions. R and c are just calculated. So let me change it to dr dc. It should be okay. Yeah, because this dr and dc is just the directions. This r and c should be, yeah, the distance. So let me just run it. Yeah, no, there is another error. The list index out of range. Yeah, I have to check the dist first because this dist can be 0. If it is 0, I'm gonna continue. If this dist equal to 0, I'm gonna continue. Yeah, because this dist is 0 means this ball cannot go down. Yeah, but I don't think it can solve the problem. Let me just try. Let me delete the directions array. And this list index out of range. This neighbor. If this equal to this neighbor and it is less than pass p. Let me print out this neighbor. Maybe this is wrong. I think I also need the this index out of range. That is it. Yeah, let me just print out the neighbor. Maybe the neighbor is wrong. Yeah, the neighbor is 25. This array is just out of the neighbor goes out of range. Yeah, let me check. Maybe there's something wrong with the check function. Yeah, because here I made a mistake. So if the ball will go into the hole, it means I don't need to. Yeah, I don't need to minus the distance. If it is not, if it didn't go through the hole, I need to minus dr and c minus dc. Yeah. Now let me try it. Oh. No, I think yes, I think it should be like this. This is the distance and directions and R and C, and this is the dr and dc. Yeah, now let me check why it is wrong. K error 3 and 5. Yeah, and here I also needed to change this to dr and dc. Yeah, because this is the directions. Now let me just run it. Yeah, as you can see, it works, and it passed a lot of my testing cases. Yeah, this is just a typo for me, I think, dr and dc, because this is the directions. Here is just some logic. I made a logic problem mistake. Yeah, because if it hit into the wall, it will go back. I need to use a minus dr and dc. If it didn't hit wall, if it goes through the ball, I can just return with the directions with r and c and the directions and the dist. And also, you need to take care of this one. If I didn't use the dist equal to 0, it's gonna hit into the wall and go back. Because for example, this ball hit into the wall and go back, it will still be a possible result, but it cannot be like that. Let me just run it. Yeah, if I didn't use this condition, you can check the first example. So for the first example, it is a D, LUL. So for LUL, it is okay, but there is a D. So this D just means it will go inside. It will go inside the wall, but that is not possible. Yeah. So I need a check if this distance equal to 0. I cannot let the ball just go down. If it goes down, it will go to left. Yeah, if so this is a mistake I made while I have this result. If the distance is still 0. Yeah, so it will go down. Yeah, this is because for the while check. If it is from here, I use this while check. It will go down, but while I'm return, I'm gonna let it go back. Actually, this is wrong because it cannot go down. But for my programming inside the check function, I simulated it like that. I simulated it can go down and go back. Yeah, this is something inside my programming. I gonna let it stay at position, but I've already put a D at the beginning. This is gonna be a mistake. So this means if the distance is just 0, it means it will not go up, down. It will not go hit into the wall and go back because that is not possible. The ball cannot go inside the wall and come back. I just simulated it like that because this is easy for the calculation. If it is not going to the wall, it can go anywhere else. If the distance is just 0, I mean the distance is 0, it has no influence for the shortest path, but it has influence for the result because the result cannot have a D. So we need to have another check. If the distance is 0, I just need to use a continue. Yeah, let me just submit it to check. I think it's gonna be wrong because I print out a lot of things. Yeah, let's just wait. And at the it passed. As you can see, it's 5% because I didn't delete the print part. Let me delete all the print part. Let's check the final time. Let's check if there's any other print. No, there's no other print. Now let me submit again. After that, I'm gonna analyze the time complexity. Yeah, as you can see, now it's 75%, but sometimes while I submitted, it's gonna have 100%. It doesn't matter. And I think this gonna be a pretty fast algorithm because I used the Dijkstra's algorithm to solve it. And the time complexity is just E log V. E is the number of edges, V is the number of vertices. Yeah. So let's check the size of the maze. It is 100. It means the number of the edges gonna be n square, and the number of vertices. The number of the edges. Let me check the number of the edges. It's gonna have 4 directions. 4 directions. Yes. So the number of the edges gonna be n squared because it's gonna be a sparse graph for a matrix because there are only 4 directions. Yeah, n squared, and the number of vertices will still be n squared. So the time complexity is n squared log n squared. So it is n squared log n. So this n squared is just 10,000. It's not a big value. That is why it is so fast. Thank you for watching. See you next time.